result of certain interventions made by the government. We indicated last week that when government comes into a market and impose a price system or a price floor, it can result in a market disequilibrium situation. Okay, so there are certain instances where the market will be in a state of what is equilibrium, where the demand for a particular product will not equate the supply of that particular product. We do sometimes define what price is, what for, and we looked at certain cases where the market will be an equilibrium. The government will intervene in the market proceedings to introduce a price floor, and what the resulting effect will be on the equilibrium demand and equilibrium price of that particular product. These were some of the scenarios that we looked at last week. So we just want to recap on some of the last part of the calculations that we did actually in class out of 7 minutes. We introduced a bit of this equilibrium in the class at the patient. So we want to bring the class back to equilibrium, where we are all on the same footing, doing the same thing, doing the same book, and being all on the same page. Okay, so let's start over again, particularly on the quantitative approach to market equilibrium. We looked at 2 scenarios. The single commodity case, and that one is okay. All right, so let's look to the 2 commodity case. So we are having a situation where we are trying to be a little bit more realistic by saying that, of course, the consumer consumes more than one product. The consumer consumes several products, several goods and services and bought in the market. But to simplify the analysis and to also sound a little bit more realistic is to say that let's assume the consumer consumes only 2 commodities in the market also. Now for these 2 products, the demand and supply functions or equations have been given. And so we have the quantity demanded for the 2 products, product X and what? Y. So the quantity demanded for product X equals 41 minus 1.5 Px plus 0.5 Py. Okay. Then we have the quantity supply of product X, Qsx, to be equals minus 2.5 plus 7.5 Px. So let's take the equation 1, equation 2. On the other side of the product Y, the quantity demanded for it, product Y equals 46 plus Px minus 2Py. And Qsy equals minus 3 plus 16Py. And for this, let this be equation 3 and this be equation 4. Okay. The question is for us to find the equilibrium price and quantity for the 2 commodities X and Y. Then we said that to do so, we follow the same approach as we often do. And this approach is that we all know as equilibrium. As equilibrium for commodity X, the quantity demanded for it must equate the quantity supply of it. And we know that the quantity demanded for product X is given as 41 minus 1.5 Px plus 0.5 Py. And that equates the quantity supply of product X, which is given as minus 2.5 plus 0.5 Px. So this is the equilibrium of product X. So let's simplify this by grouping items here. 41. Then take the minus 2.5 from that gives us plus 2.5 plus 2.5 equals 7.5 dx plus 1.5 dx. 41 plus 2.5 equals 43.5 equals 7.5 plus 1 gives us 9px. Yes. All right. We open 0 back to 5. So 0.5 y across. And that gives us 1 minus 0.5 p. Okay. So here we should have 100 minus 0.5 p1. Okay. So let's call this equation 5. Okay. So we have equation 4 over there. Then for cohority y, similarly, they are equilibrium when the quantity demand for y equals the quantity supply of y. The demand for y is given as 46 plus Ex minus 2 P1 equate minus 3 plus 16 P1. Again, we can group like them. So we have 46 plus 3 equals, let's the final start in order. So we take Px and minus 2P1 across. So that gives us minus Px plus 16 Py plus 2 P1. So this finally gives us 49 equals minus Px plus 16 plus this gives us 18 P1 for that equation 6. So far, so good. Okay. So let's write out the two equations. Equation 5 and equation 6. Equation 5 is 43.5 equals 9px minus 0.5p1. Equation 6 is 49 equals minus px plus 18p1. So the idea is for us to solve these two equations simultaneously. And this is where goes and goes out of hand. Okay. So as I indicated, at this particular point, we really do not care how you find the value of bx and p1. You can use substitution, elimination, you can use matrices, you can even use logarithm. We really do not actually care about how you solve these two equations simultaneously. Whichever method or approach is easier or straightforward for you, you can go ahead and use it. But at the end of the day, we should all arrive at the same. Okay. So lastly, we try to use matrices. And in doing so, because it was your first time, really when you understand it, it's simpler for you to use, and you always want to use it because it's straightforward and a little bit more easy. How do we use matrices? We said that there is what we call the Cremer's rule of matrix. The Cremer's rule. And that rule says to find the value of two unknowns, for instance, in these two equations, is to say that dx equals the determinant of a special matrix A1 divided by the determinant of matrix A. Yes, for a moment, follow through. I'll explain everything in bit for you. And that BY, on the other hand, will be equals to the determinant of a special matrix called as A2 divided by the determinant of matrix A. So in both cases, they are divided by the same denominator matrix A. Okay. Let's form our matrices from our simultaneous equations. We said that we can cast these equations in a matrix form. How do we? On the left-hand side, we have two constants. They are 43.5 and 49. So they constitute what we call the vector of constant terms. Vector of constant terms. So let's write it out. They are 43.5 and 49. So vector of constant terms. Because they are constant. And that equates, say the cos sign here. We create our vector of, our coefficient matrix. Our coefficient matrix. How do we do that? The coefficients of these terms to create a coefficient matrix. For 9px, the coefficient is what? 9. For 0.5py, the coefficient is minus 0.5. For minus px, the coefficient is minus 1. And that of 18py, coefficient is 18. So this will give us what we call a coefficient matrix. But we know that we have x and y in both terms. So we have to multiply the coefficient matrix by the respective x, px and what? Py variables. So what it means is that if we expand this bracket, we are going to go back to the same simultaneous equation. If you take px and py in this particular column and multiply by the first row here, we are going to have 9px, which is what we have here, minus 0.5py, which is what we have here. At the same time, if you take this to multiply by this, the px multiplies by minus 1, that gives us minus px. The py multiplies 18, and that gives us what? Positive 18py. And we all know that equates to our vector of constant terms. So we can let our vector of our coefficient matrix be A, our vector of unknown variables here, because it's vector of unknown variables. So let that be x. We can let the coefficient vector of constant terms here be n. All right. So now we know what A is. From this formula, we need to find A, and so we are able to arrive at what? At that A, which is the coefficient matrix. The idea is to find the determinant of the coefficient matrix A. How do we find its determinant? Because in the formula, we have the determinant, not just A, but the determinant of what? So the determinant of A is found by a cross multiplication. So we multiply 9 by 18 and subtract from that product minus 1 by minus 0.5. And that gives us the determinant of what? A. So that will be equals to 9 times 18 minus into brackets minus 0.5 times minus 1. So this gives us 9 times 18 gives us what? 162 minus 0.5 times minus 0 minus 1. That gives us what? 0.5. So we have minus 0.5. So this gives us 161.5 as the determinant of what? Of A. Now we want to find in the formula, we need to know A1 as well as A2. These are special matrices. And we indicated that to find the matrix A1, special matrix A1, is to come to matrix A and substitute the first column of matrix A with this, and that becomes matrix A1. So matrix A1 will be given us, when we take this to substitute this, we are going to have 43.5, 49, and this will remain. So you have minus 0.5, and then what? 8. So this is special matrix A1, we want to call it. By the formula, we need to find the determinant of that special matrix A1. And so the determinant of the special matrix A1 will be equal to, again, the cross multiply. So it's going to give us 43.5 times 8 minus 49 times minus 0.5. Okay, so we cross multiply the numbers on the principal diagonal, we call this a diagonal, and subtract from that this times that. So this gives us 43.5 times 8. It gives us what? 43.5 times 8. It gives us 70.783 minus 49 times minus 0.5 gives us what? 24.5. So because this is minus times minus will give us what? Positive. So in the end, this is going to give us this plus this. What would that give us? 807.5. Okay. So we are able to find the determinant of A1. Now we are left with the determinant of what? A2. So let's find matrix A2. And that is also found. We see how we found matrix A1. In this case, we are taking the vector of constant terms to replace not the first column, but the second column. So this gives us, so here 9 minus 1 will remain, but this will now be replaced with that. And that is 43.5, 49. And that is matrix A2. Again, we need to find the determinant of A2, which will be equal to 9 times 49 minus 1, 43.5. So we multiply this by this and subtract from that this times this. All right. So this gives us what? 9 times 49 gives us 41. Then we have minus 1 times 43.5 will give us minus 43.5. Then there is a 1 here. And so we multiply that 1 by minus 1 by minus 43.5 is going to give us what? Plus 43.5. So the addition will give us what? 484.5. Next second. So let's now substitute the determinant of A2, A1, and A into our formula to find the price Bx and B1. Okay, so we say that Bx there because determinant of A1 is what? 807.5 divided by determinant of A 161.5 equals 1. Let's divide 807.5 by 161.5. Gives us 5. So the price of commodity X, the equivalent price of commodity X is 5 Ghana cedis. Then we come to the price of Y. The determinant of A2 is calculated here to be what? 484.5 divided by the same determinant of A. So in both cases, we are divided by the same determinant of what? Of A, which is what? 161.1. And this gives us 3 Ghana because of 3 cities. So the equivalent price of X and Y have been calculated. So the 5 and 3 Ghana cities per second. So those are the equilibrium prices of X and Y. Yes. Well, 161 point. Yeah, minus 0.5. Minus 0.5 times minus 1. So it will give us positive. However, outside the brackets, we have negative. So we are maintaining that t. So that what we have in the bracket is positive. Right. Now the equilibrium quantity. We find the equilibrium quantity for X and Y. Yes. Yes. Here. Determinant of A. Here. So we should separate the bench this one. So minus. Oh, it's okay. All right. Same. That is what we do. Thank you. No problem. Thank you very much. All right. Yes, we can use a different. So I'll show you something here. All right, so let's find the equilibrium quantity for X and Y. We have found that for the price of X and Y. So let's find that for their equilibrium quantities. So define the equilibrium quantity for X. You can use either of them. The demand or supply equation for product X to find its equilibrium. Should we use demand or supply? So equilibrium quantity for product X, let's use demand. Because QDX equals, so we have 41 minus 1.5 px. Our equivalent price is now what? 5 Ghana cedis. So in the brackets 5 plus 0.5 p1, which is what? 3 Ghana cedis. So this gives us 41 minus 1.5 times 5 will give us 1.5. We may need to get will give us 7.5 plus 0.5 times 3. 1.5. So this gives us 41 minus 7.5 plus 1.5 will give us 40. Give us 30. 35. So the equivalent quantity for product X is 35. To find the equivalent quantity for product Y, is to substitute Bx equivalent price Bx and that of By into either the demand or supply equation for products one. Okay. Which one should we choose? Okay, so let's use demand. So you have Ty equals 46 minus Bx. Our Bx is what? 5 Ghana cedis. So 46 plus 5 Ghana cedis minus 2 BY. Our BY is what? 3 Ghana cedis. So this gives us 46. 5 minus 6 will give us minus 1. And that equals to what? 45. So our equilibrium quantity for product Y on the other hand equals to 45 units. All right. Any questions? So as I said, there are several methods that you can use. There are several methods that you can use. You can use elimination or substitution. You can use logarithm. I feel this is simple and straightforward. Because it's your first thing, and you see it a little bit that's continuous practice to make it easier, straightforward. Now, just explain how we can use substitution or elimination to solve. Okay, so we have two equations. 43.5 equals to that, and 49 equals to that. To solve these two equations simultaneously using substitution is to either make Px or P1 the subject, either in equation 1, this equation, or this other equation. So we can make Px the subject from equation, this was the second equation, because it will be simpler to do so. If you take Px across, it becomes minus Px across, it becomes what? Px. Then we take 49 across. So you are now going to have Px equals minus 49 plus 18 what? Py. Then you substitute that Px into this equation. So wherever you find Px, you substitute that. So here we have Px, you substitute minus 49 plus 18 Py in place of this particular Px. And then you solve for Py. All right? And that will be the real price for y. Having found Py, I'll come back here and put Py either in this or in that to find the value of what? Px. So when you go home, you can find it. Okay. And that is substitution. You can also use elimination. So whichever method you feel is easier, you can go and use it. Very. Any other questions? All right, so let's continue. Okay. Okay. Yes. Yes. Yes.
Then maybe I put the formula.
Yes.
Then I don't know where it is. I provide it.
I think it will be good to share with because in a better situation. I think it will be good to show where it because in a better situation, sometimes students always fail to resist the temptation to look at other people's work. And so we may assume that for putting a formula and not showing working, but giving us answers, probably you look at somebody's work to get the answer. So it should be better to show. Okay. Multiple. Yes. About yeah. How many? I really can't. Yeah, you. Please come in. Yes. Or you can. Yes. Price of one affects the quantity money for the demand. Okay. So somebody is trying to find out. So these commodities X and Y will represent Milo and Bombita. Okay, so this will be Milo and what? Bombita. Depending upon whether the relationship between the price of Y and that of the demand for X is positive or is negative. Earlier we established that what's the nature of the two commodities? Are they substance or complements? So they are substitutes. So they could be Milo and what? Bombita. So yes, somebody is trying to find out how we can illustrate a change in price in, let's say, Milo or X, how that can affect the demand for another product, one. Diagrammatically, they can illustrate that. Okay. So we have two separate products. I'll come back to that in our ending part of this particular lecture, where I'll give you a scenario about how two commodities, either they are related in terms of substitute or complement, how the change in price of one can bring about a change in the demand for. We will look at that by the close of this particular session. Okay, yes. Yes. Trying to make the effort to finish it up. Okay. Please, if you don't understand it, just answer. It's not that too difficult. And let's not make up our mind that they are not going to do it now. Just want to do something that we can pass and go. We are not really so much concerned about the exam testing. We are concerned about what we are going to get out of this program, how you are going to implement these concepts. Some of them, of course, you may not implement them at your basis. But the idea is that it will require your mind to understand how market dynamics operate. Okay? So even though you may not necessarily apply it at your workplace, but you know that something like this exists somewhere. Okay, and this is how the market functions. Okay, so please let's have some interest. As I told you from the beginning, invest your interest in what you are doing and your effort. And you find that everything will be very easy for you to watch, for you to understand. So don't be so much concerned about exams and how to get the pass market. Let's be concerned about what we are getting from this. Okay? The understanding of what we are doing here is so much important to us than the exam. Even though we appreciate the fact that you all pass or you all need to pass the what? The exam. Okay, so you'll be fine. All right. Okay. So now we are done with this. So we have some other trial questions that you can go over and try. For instance, this we worked it earlier. Okay, to find the given price and quantity, equate these two equations. So we did that in class earlier last week. So we also worked this. Yours is to go and try this one. So we have the two commodity case where we are dealing with two related products, fish and beef. And so this is the simultaneous equations here that we solve together. Here we are not giving the demand and supply for fish and demand and supply equations for what? For beef. They have already been simplified into these two simultaneous equations for us. Our responsibility here is to just find the price of beef and the price of what? Fish. By solving these two equations simultaneously. So as we have done here, so these are a replica of what we have here. Okay. And so you just either use matrices or you use elimination or substitution to solve to find the value of B1 and B, and that of what? BM. So for example, you will make BM the standard here. You take this across and take this 87 across so that BM becomes 18 PB minus 87. Then you substitute that into this. And that is the method of substitution. And the value of what? The value of PB. Having found the value of PB, then you can now substitute that into either this or that to find the value of what? BF. And by that question is solved. We have found the equivalent price for beef and that of what? For fish. All right. This is also demand and supply equations for two interdependent commodities. So commodities 1 and 2, the demand equations and supply equations are given as follows. So you are supposed to go through this same process to find the equivalent price of commodity 1 and that of commodity what? Commodity 2. So it's an approach that we did here. So it equates QD1 to QS1. Equate QD2 to what? QS2. Because at equilibrium, quantity demanded for product 1 must equate the supply of what? Product 1. Similarly, quantity demanded for product 2 must equate the supply of what? Product 2. So you equate them, and then you solve to derive these simultaneous equations, something similar to this. And now either use substitution and make matrices to solve the values of the equilibrium ones. Prices for commodity 1 and 2. All right. Now, I want us to discuss something very important. We want to look at the case of inverse demand functions. Inverse demand functions. Any questions? Any questions? So what we have been looking at so far is that if you consider this demand equation, you have QDX for example equals to that. Then if you look at the supply, you have QXX equals to that. We call this direct demand and supply equations. They are direct in the sense that we have the supply or the demand, quantity demand for the product being on your left hand side, and prices being on your right hand side. Direct demand and supply equations, where demand equals to this and supply equals to that. We can have a scenario where we have an inverse demand and supply equation. Where the demand equation, instead of being starting with the demand, rather start with price. In other words, we can make price the subject, Bx the subject from this equation. So that Bx will now be equals to 41 plus 0.By minus QDX. In that sense, it's still a demand equation, but it's no longer a direct demand equation. It's now an indirect demand equation. So you can have a situation like that, where we are given indirect demand equation, demand and supply equation, and not what, and not direct. When we find ourselves in that case, what do we do in finding the equivalent price and quantity? So we want to look at something like that. But the right place, you have to see. All right. So let's look at this example. Let's look at this example. Assuming that the demand function for a particular product is given as P equals
Down to this. This one is fully tapped, so let's switch out. So I don't mistake it.
All right. Assuming that the demand function for products, a particular product given us B equals minus 4QT times 120. So this is our demand function or equation. Then we have B equals 1/3 QS plus 29. And this is our supply function. Find the equilibrium price and quantity. So these are inverse demand and supply equations. So you realize that the case of demand, it means that the quantity demanded for products, that particular product equals something. The relevant sentence is what? Price. So that means it's an inverse demand function. The case of supply is the same. It's an inverse supply function. So we have to find the price and what? Equilibrium price and quantity. How do we find that? So there are two ways to do this. You can either equate this to that, because we know at equilibrium, demand equals to what? Supply. So this is your demand, this is your supply. So you can equate them to find your equilibrium quantity. But that approach interestingly will allow you to find the equilibrium quantity before the price. In the case of the direct demand and supply equation, we found the equilibrium price before the equilibrium quantity. So when it is indirect and you work with them as they are, you find the equilibrium quantity first before the equilibrium price. You can also decide, instead of working with them as indirect equations or functions, you can make them direct before you start your calculations. And to make them direct is to make QT the standard here and make QF the standard here. So that they become what? You convert them from the indirect to what? Direct before you work. Either of which should give you the same answer. Okay. So let's solve this to find the equilibrium price and what? Quantity. So you know at equilibrium, our demand equals what? Supply. Here our demand is given minus 4QT. Now let's pay attention to this. Because at equilibrium, demand equals to supply. When we are equating these two equations, there is no need to differentiate the quantities. After all, at equilibrium, they are all what? Same. So we just put minus 4Q plus 120 equals to 1/3 Q plus 29. Okay? So they have equated our demand to what? Supply. Okay. The idea is to make you the circuit. So how do you make you the circuit? We have 1/3 here. So we can multiply through by what? By the 3 to do away with the fraction. So doing so will give us, we have 3 times minus 4Q plus 120 times 3 equals 1/3Q times 3 plus 29 times 3. 3 by minus 4 as minus 12Q plus 120 times 3 as what? 3 what? 360 equals 1/3Q times 3. This cancels that gives us Q plus 89 times 3 gives us what? 87. Okay. So we make Q the what? The subject. So we can take 12Q across and then 87 to the other side. So we have 360 minus 87 equals Q plus 12Q when we take this across. All right. So 360 minus 87 gives us what? 273 equals Q plus 12Q gives us 13 what? Q. So we divide here by 13, here by 13. Our Q equals what? 21. So our equilibrium quantity Q equals to what? 21. Then we have to find our equilibrium price. So realize that it's the other way around. So find the equilibrium price, yes.
And Q plus what?
Yes.
So that don't have the Q outside
The 12Q, and so we took this 12Q minus 12Q across. And it's going to join this Q because they have like terms. They are like terms, okay? And so once it crosses minus 12Q crosses, it becomes positive 12Q. And because it's a like term to that of Q, we just add it straight away or directly to the Q. And that gives us the 13. All right. So to find the equilibrium price is to substitute this equilibrium quantity either into the demand or what? Supply equation. So which one do you pick? Let's pick demand. So our equilibrium price P will be equal to minus 4Q. So in place of this, we will put 21 plus 120. So our equilibrium price P will be equal to 4 times minus 81, 4 plus 120. So our equilibrium price P equals to what? 36 dynasty. So this is how you can find equilibrium price and quantity when you are given inverse demand and supply equations. So somebody could have decided, as I said, to compare them to the rates before working. Well, that will take a lot of your time. You can just straight away equate the two equations and then try to find the equilibrium quantity. Substitute in either of them to find the equilibrium price. Yes. How do we get which one? So when we equate, we have 1 over 3 here, 1 over 3 cube. And to do away with that particular 3, which is part of the fraction, is to multiply through the entire equation by 3. So that 1 over 3 cube times 3, the 3 will cancel. So that we now linearize or make the equation simple instead of some of the terms being in fraction. So doing that gives us this. Okay. Very good. Now let's introduce something. We said that sometimes government goes into the marketplace either to impose taxes on goods and services or to give subsidies to producers in order to reduce their cost of production so as to make the product be sold at, yes, 360 minus 87. So we do this across, leaving us with 360. And we have 87 here. And because 87 and 360 are like things, so we do the 87 to join this. So crossing the equal sign became negative. So you have 360 minus 87. And that gives us 270. All right. Now, we are going to assume that government has gone into this particular market to impose a tax on the product. And the tax that the government imposes is 13 Ghana cedis per unit of the product. So you have government imposing a tax of 13 Ghana cedis per unit of the product. Per unit. Now we should understand that when government imposes a tax on a product, it is a supply equation that is affected. Okay, it is a supply equation that was affected. So given our supply equation to be thus, when government imposes a tax on a product, automatically the price of the product will go up. And so what we are going to do is to look at the new equivalent price and quantity, given that government has imposed a tax of 13 Ghana cedis per unit on the what? On the product. What will happen to the initial equivalent price and what? Quantity. We know this to be our supply and demand equations. And as I said, when the tax is imposed, it increases the price of the what? The product. So we are supposed to add the tax component to the supply equation. If it was the subsidy that the government gave, we would subtract that amount of subsidy from the supply equation. So on the imposition of the tax, we still have our demand equation to be minus 4 QD plus 120 as our demand equation. Our supply equation, however, will now be 1 over 3 QS plus 20 what? 9 plus the tax. And the tax is what? 30 Ghana cedis. So let's find the new equilibrium price and what? Quantity. Again, we know at equilibrium, our demand equals to what? Our supply. Our demand still remains 1 minus 4 Q plus 120. Our supply is now 1 over 3 Q plus 29 plus 30 gives us 40 what? 42. Good. So let's find our Q. Then to find our Q is to multiply again to convert, to take to account this fraction. So to do away with the fraction is multiply through by what? By 3. So we have 3 times minus 4Q plus 120 times 3 equals 1 over 3 Q times 3 plus 42 times 3. Again, this gives us minus 12 Q plus 360 equals this 3 cancels, this gives us Q plus 42 times 3 gives us 126. Very good. Then we send line terms. We take the 12Q across, so we have 360 minus 126 equals Q. When this crosses, it becomes what? Plus 12Q. 360 minus 126 gives us what? 2, 3, 4 equals Q plus 12Q gives us 13Q. So we divide here by 13. We divide here by 13. Our equilibrium quantity Q will now be equal to 18. Okay. Then we find our equilibrium what? Price. Our equilibrium price is found by substituting 18 into either our demand or what? Supply equation. In doing so, pay attention to the fact that the supply equation has changed. It's no longer the old one because of the imposition of the what? Of the tax. So our equilibrium quantity and price P E equals which of them should be substituted in? Demand or supply. So let's take demand. So our demand equals minus 4 Q. The Q is now 18 plus 120. So this gives us minus 18 times. So 18 times minus 4. Minus 72 plus 120. Minus 72 plus 120 gives us what? 48. So 48 becomes our new equilibrium price. So you can realize that our new equilibrium price has increased from 36 to 48. What 8 minus 36 is what? It's 12. All right. So from here, we can now ask ourselves, okay, so what is the incidence of the tax? And the incidence of the tax here is that who bears the burden of the tax? We are consumers and what? Suppliers of this and that product. The portion of the tax that the consumer must bear is the consumer incidence of the tax. And that's the what? The suppliers component of the incidence of the what? Of the tax. So let's find the incidence of the tax imposed. Now, the consumers pay the price at which the product is offered for sale in the world. So the change in price becomes the consumer's component of the tax that he pays. So the change in price, let's allow BC to be the consumer's component of the tax that he pays. And that will be because the initial equilibrium, the current equilibrium price is what? What is, so let's say this is P1 minus P0, where P1 is the current equilibrium price and P naught is the previous equilibrium what? Price. So this will give us P1 is what? 48, and P1 is what? 36. So this gives us what? 12 Ghana cedis. So the component of the tax, we said the tax is what? 13 Ghana cedis per unit. So the component of the tax paid by the consumer is what? Is 12 Ghana cedis. We can express it in a proportion. And by that, we divide the 12 by the entire amount of the tax, which is what? 13 times 100%. And this is us what? 12 over 13 times 100%. It gives us 90.3%. So that means out of the entire tax component of 100%, that is 30 Ghana cedis, the consumer pays 92.3% of the entire tax component. Now let's look at the incidence of the tax part of the producer. How much does the producer pay? So let's say that the producer of the tax that he pays is PS. That PS will be equal to the tax component. Whatever is left is going to be the amount that the producer must pay. So the tax component minus the tax paid by the producer and the consumer. This gives us the tax is 13 Ghana cedis minus the component paid by the consumer is 12. So our PS is going to be what? 1 Ghana cedi. So in proportion, that will be 1 over 13 Ghana cedis times 100%. And that gives us what? It gives us 7.7, roughly 7.7%. Meaning that the producer pays 7.7% of the entire tax component imposed on it. Okay. Okay. Now let's illustrate this analysis diagrammatically. So let's draw our demand and supply. So this is our price axis. This is our quantity axis. This is our demand equation. So this is our quantity axis, which is given as P equals to what? Minus 4Q plus 120. This is our supply. Our supply is given us, let me clean this. Our supply is giving us what? Our initial supply. It was given us what? P equals 1 over 3Q plus 29. So this is our initial equilibrium. Our initial equilibrium quantity was what? It was 21. And our initial equilibrium price was 36 Ghana cedis. Upon the imposition of the tax on the product, the supply equation changed. In other words, it increased the cost of production of the product. What happens is that the suppliers will no longer be able to supply as they used to, because cost of production has what? Has increased. And so we have a new supply equation. And this is the new supply equation where we added the tax component of what? 13 Ghana cedis. So the imposition of the tax will reduce supply. And we think that when the supply gets shifted to the left, it indicates a decrease in what? Decrease in supply. So we are going to have a new supply here, or equation here. And that new supply equation is P equals 1 over 3Q plus 29 plus 30 is what? 42. Good. So this is our new supply equation. And that new supply equation intersects both demand curve, okay, at this particular point. So this is our initial equilibrium point. And upon it, that has changed the supply, or that has brought about a decrease in supply. We now have a new equilibrium point. So let's call that E1. So the new quantity demanded, sorry, the new equilibrium quantity we calculated is now what? 18 units. So here we have 18 units. The new equilibrium price went up to what? To 48 from 36 to 48. We can call that PE1 equals what? 40. So this is our QE, which is 21. QE1 equals what? 18. So we have illustrated this diagram, but we are not done. We can be asked to find the tax revenue. When it imposes a tax in order to generate revenue. So from this scenario, what is the total tax revenue that the government will generate for imposing the tax on the product? How do you calculate that? You know that the tax revenue can be. Yes. Okay, so let's continue. So this was change your price equals. Now, what will the government get? So this is the diagram. So initially, we had a new equilibrium at this particular point E, where both supply and demand equations intersected. Okay, so the point of intersection is E. Our initial demand equation is given as this. This one. Initial supply is given as what? That. Upon the imposition of the tax, the cost of production of the producers will increase. So most of them may not be able to afford that high cost of production. So they will drop out of the market. So the supply of the product will reduce. In other words, it will shift to the left. And we have the new supply where we now factor in the component of the what? The tax. Remember when we added the tax component to the supply equation, it became this. And so this becomes our new supply equation. Intersecting the old demand equation adds a new equilibrium point E1, where the new equilibrium quantity is now 8. And new equilibrium price is 48 compared to 36 as the previous equilibrium was. The question is, how much will government generate from the tax that government has imposed on the product? So the tax imposed will generate some amount of revenue. And the tax revenue that government will be able to generate will be equals to the tax per unit multiplied by the quantity that is what? Sold. Okay, the quantity sold, or the equivalent quantity. Our tax per unit is what? 13 Ghana cedis. The new equivalent quantity is what? 18 Ghana cedis. So that is how I'm going to calculate tax revenue. So 13 times 18 Ghana cedis, it times 18 units will give us what? 13 times 8. It will give us 2, 3, 4. So this will represent the entire tax revenue that the government will be able to generate for the imposition of a tax on the product. Okay. All right. Yes. Yeah, our equilibrium price will be 36. Yes. 21. Yes. Sure. 8. Okay. Yes.
Because why is revenue is price
Quantity, yes. We are looking at, sorry, we are looking at the revenue that the government will generate from the tax. It produces revenue. All right, thank you. Well, it's an important question because it's leading me to what I'm going to talk about. We realize that from 36 to 48 is an increment of what? 12 cities. It's an increment of 12 cities. Okay. Then the producer must pay only what? 1 city out of the 13 Ghana cities. So what it means is that though the imperial price has increased from 26 to 48, question is currently how much will the producer be receiving per unit of the product sold? How much will the producer be receiving per unit of the product sold? No, per unit of the product sold. The equivalent price increased from 36 to what? 48. After government imposed a tax of what? 13. The tax of which the producer is paying 1 cedi and the consumer is paying what? 12 cedis. Question is currently the equivalent price is 48. How much will the producer receive per unit of the product sold? How much? Okay. So the price that the producer will now be receiving will not be 48. It will not also be 36. It will be 1 cedi less than 36. Does it make sense? Why? Because the tax is 13 Ghana cedis. So though currently the consumers are paying 48 for the products, the 48 does not go to the what? The entire 48 per use of the product does not go to the producer or the supplier. Okay. Also, the supplier is not even getting 36 because the supplier must also pay 1 cedi component of the what? Of the tax. So if 36 to 48 will give us 12, the 12 is not the same as the amount of the tax, which is 30. So meaning that the producer is receiving 1 cedi less than 36 because he must also pay 1 cedi for each unit of the product sold as a component to the what? Of the tax. So the producer's price will actually be what? 35. Will actually be what? 35. So the producer is not receiving 36, he's receiving what? 35. And the consumer is paying 48. The government is receiving 30. The producer is receiving what? 35. So the 13 plus 45 will give us what? 48. Did you understand that? 13 plus the 35, which the producer actually receives for selling each unit of the product, will give us the equivalent price of what? 48. This 48 contains 13 cedis as what? As tax. So that is 48 minus 35 plus 13 Ghana, which goes to the government as a tax for a tax being imposed on the product. Excellent. So you realize that initially we said that the area below the demand curve, but above the equivalent price, is known as what? The demand was, the consumer was surplus. And the area below the equivalent price, but above the supply equation, is known as what? The supplier or the producer was surplus. So when the tax is imposed on the product, increasing the price from the initial equivalent price of 36 to 48, it means that part of the producer's surplus is now going to government in tax revenue. So the consumer surplus will reduce by this area. Did you understand that? On the other hand, the the producer surplus will reduce by this area. Because the tax has been imposed on the product, part of the producer surplus will be lost to the government in tax revenue, and part of the consumer surplus will also be what? Lost to the government in what? In tax revenue. Just that the amount of the consumer surplus loss is more than the amount of the producer surplus loss, because the consumer pays 12 cities out of the what? The tax of 13 Ghana cents. Did you understand that? Initial equivalent price was 30 and 36. When the tax was imposed, the initial equivalent price increased from, so the initial this was the area below the market, but above this initial equivalent price of 36. This area represented the consumer surplus. The area above the 36 initial equivalent price, but below the market, that area represented the what? It represented the consumer surplus. Now the tax has been imposed, and the consumer has lost part of the surplus to government as tax revenue. By how much? By 12 Ghana what? 12 Ghana cedis. So the part of the consumer surplus that is lost to the government can be calculated to be this particular area. So let me draw it out. So we have this. So this is the consumer surplus. Part of the consumer surplus that is lost. I mean this area. And this represents part of the producer surplus that is also lost to the government in tax what? In tax rate. But there's something interesting we have to take note of. This part of their surpluses that are lost, they do not go to the government in tax revenue. Why? Because in calculating the government's tax revenue, we multiply the tax per unit by 80 and not by what? 21. So that means this component of the loss in producer and consumer surplus is not part of the government tax revenue. So the loss of that part of the loss of consumer and producer surplus, that does not go to the government in tax revenue. The sum of the two is what we call deadweight loss. Deadweight loss. So we call this a loss to the system. It's that particular part of the consumer surplus and producer surplus that does not go to the what? The government in tax revenue. It does not go to the consumers, neither does it go to the what? The producers. It's a loss to the system. Okay? And so what it means is that it's a loss in the welfare of the consumer if this 21 has been supplied and not what 80. It's the amount of loss the consumer will experience if 21 is not supplied and rather 18 is what is supplied. And similarly, it's a loss to the suppliers in the sense that they could have generated more revenue if they had supplied 21 and not what 18. So the sum of the losses in consumer surplus and that of what producer surplus is what we call the deadweight loss. So this area here is that part of the consumer surplus loss to the government. Sorry, that is loss to the system and that not go to the government. And this also represents that part of the producer surplus loss that does not go to the government. The only area of their losses that go to the government is this area. Because you can't meet the government tax revenue. Remember, we are applying 18 by the tax what? By the tax rate. In practical sense, the deadweight loss represents a loss to the system, as I said. For instance, when you work with this, when you work with GR, sometimes what happens in reality is that they go to do some tax assessment of the business somewhere. And these tax agents who go to do the tax assessment Assuming they have come to Madam's business to do a tax assessment, and she's supposed to pay 10,000 in taxes. The 10,000 is to be collected from her and given to us, government of Ghana. Some of them are a little bit, they are a little bit not special. Let me put it in a very polite way. So when they come to do the tax assessment of 10,000, they tell the business owner that your tax is supposed to be 10,000 Ghana cedis. Let's have a deal. Give us 3,000 Ghana cedis. Pay 5,000 Ghana cedis and keep 2,000 Ghana cedis. That is what some do, not all of them. So the 5,000 that goes to the government is government tax revenue. It's supposed to be 10,000, but only 5,000 goes to the what? Goes to the government. The other 5,000 that does not go to the government, okay, but remains in the pocket of the tax collector. And that is the 3,000 goes to the pocket of the tax collector. It's the dead weight fund. Dead weight fund. It's a law of the system that does not go to the what? It doesn't go to the producer. It doesn't go to the consumer. It doesn't also go to what? The government. So they call that the dead weight loss. Yes. So it's a loss to the system as a result of market inefficiencies. Okay, so these are market inefficiencies, particularly inefficiencies in tax administration can bring about dead weight losses, where part of the taxes that are supposed to go to the government end up in the tax collected pocket. Does not go to the government, it doesn't go to the consumers of the product, it doesn't also go to the supplier of the product. It ends up in the pocket of the what? The tax collector. So we call that a dead weight loss. It's a loss to the what? A loss to the system. Yes. In that case, it's an indication that the market has what? The market has failed. So we look at market failure as a whole topic, and we look at the causes of market failure. Okay. Yes. 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 To 80. Exactly. So like that's why we multiply the tax rate by 80. Yes. Yes. So the debt rate, as I said, is the loss in the welfare of the consumer for having less of the product was supplied in the market. That particular welfare loss supplied the consumer experience for having 18 instead of 21 is the consumer's part of the debt weight loss. And that particular loss is the revenue of the producer. Supplying 21, but supplying 18 as a result of the imposition of the tax is the producer's component of the debt weight loss. This is. The question is, these losses in the welfare of the producers and consumers, in monetary terms, where does it end? Or where is it? It's a loss to the system. It ends up in the bucket of individual tax collectors who do not give all the tax revenues to the government when they collect those tax revenues. So we call that a loss to the what? A loss to the system. Yes. Yes. Is there a way we can do away with that weight loss? Yes, we can do away with it. Yes. 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 So take back the system. The question is, When they take, are they taking the money from you? So if we take the system, when the taxpayer cannot take the money directly from the taxpayer, then we are as much as possible reducing the debt with what? Loss. So it's possible to reduce the debt with, okay, by enhancing our tax administration system, we can reduce the debt with what? Loss. But if there are so many loopholes in our tax administration system, allowing tax collectors the opportunity to pocket some of the tax revenues, then that means we are providing an avenue for more debt with losses. All right, let's continue. Somebody asked a question about how changes in price of one product can affect the demand for another. We looked at that. In fact, we looked at that last 2 weeks. When we looked at last week, when we looked at the various dynamics in the market, where we said that sometimes the demand for one product will be increasing while the other remains one, while the supply remains constant. And also the case where the supply will be increasing while the demand remains one, constant. And the case where all of them may changing at the same time. Now we want to look at a scenario where let's assume that government imposes a tax on cement. How will it affect the demand and supply? The supply, let's say the supply of housing in the housing market. Assuming that government has imposed a tax on cement, how will that affect the equilibrium quantity and price of housing in the housing market? So let's look at a simple scenario to answer this question. So assuming that this is our demand, yes. This is our price and this quality as this. So demand and supply. So let's say this is the cement market. So this is our supply, initial supply. This is our demand. Initial equivalent as E, given as initial quantity E. And then this is our initial equivalent price. So the imposition of the cement tax will increase the cost of production of what? Cement. So most suppliers of cement will reduce the quantity that they are able to supply to the market because of the high cost of what? Production. So supply automatically will shift to the left. And so we are going to have a new supply that we call that ST. And that will establish as a new equivalent quantity called that QE1. Then an increase in the equivalent price PE to PE1. PE1. So imposition of a tax on cement increases the cost of production of cement and thereby reduce the supply of cement and hence increase the equivalent price and reduce the equivalent quantity demanded for cement. What would then be the implication of this for the housing market? When we draw the demand and supply equation curves for the housing market, we have our price and our quantity. So this is our supply, and so our demand was supply of housing. Initial equivalent of housing, initial equivalent price per unit of a house in the housing market. So, given that the price of cement has increased because of the increase in production, and thereby reduction in the supply of what? Cement. What will be the effect of the increase in cement on the supply of housing in the housing market? So the supply of housing will also what? Reduce by shifting to the what? To the left. Because the cost of producing a house will now also increase following the increment in the price of what? Cement. So let's say this shift from S to SS1. So a new equilibrium will be established as E1 here in the housing market, where the rent or the price per unit of a house in the housing market will increase from EE to BE1. BE1. So that is the nature of the interaction that takes place between changes in the price of one product and then its effect on the demand and supply of another one. another product. Actually, this was a question that came in the exam last year for students to analyze the nature of the relationship that takes place between the price of one product and then the demand and supply of another what of another product. So they were expected to do this and all right. You can start with that. Next one. One. All right, so we are done with equilibrium analysis of demand and supply. So we have 40 minutes. We want to look at what? 40 minutes. So we want to look at yes. Slides for I think the slides already covered that. Yes, that we didn't make it more practical. Okay, we didn't make it more practical by naming the product. Okay, but maybe I'll look at that and see how we can survive with that. We have not even started today's topic, but let's start and end somewhere before the next lecture. All right, so let's look at the concept of class. Oh, concept of class. Okay. All right. So, what is classes? Now, when we try to, yes. Excellent. So when we talk about elasticity, we are basically referring to the degree of responsiveness of demand or supply, okay, to changes in any of the factors that affect demand or what? Demand or supply. So what it means is that we can have demand elasticity of, what's the name? Elasticity of demand and that of elasticity of what? Supply. Where the case is that of demand, then that becomes elasticity of what? Demand. So elasticity of demand basically measures the degree of responsiveness of consumers' demand to changes in any of the factors that influence the demand for that particular product. And we came across the factors that influence the demand for a product. We mentioned the price of later product, the income of the consumer, etc., etc. Anytime any of this and preference, anytime any of these factors changes, what it means is that the demand for the product will also what? Will also change. So what it means is that we have price elasticity of what? Demand. Meaning that we are looking at the responsiveness of the consumer's demand to changes only in the price affects the demand for another related product. What? One. We call that the cross price elasticity of demand. The question is, how do we calculate the? So let's look at price elasticity for a moment. What is price elasticity of demand? So we have already defined that to be the responsiveness of consumer demand to changes only in the price of the what of the product. So for that we call it price elasticity of demand. How do we calculate that? We divide the percentage change in quantity demanded for the products by the percentage change in the price of the ones of the product. Now we have two types of price elasticity of demand. We have what we call the point and arm elasticity of what? Demand. The point elasticity of demand here tries to measure changes in the demand of the consumers given a particular change in what price. In other words, it tries to measure an assault at a particular point on the demand curve, where the arc elasticity of demand, price elasticity of demand, tries to measure the elasticity of demand for a price elasticity of demand for a product over a given range. This, let's say, from A to B on the demand curve. But in the course of our discussion, we are going to look at the point elasticity of what? The price point elasticity of what? Demand. Where we try to measure the elasticity of demand for a particular product at a particular point on the demand curve. So aside calculating our price elasticity of demand with the formula change, percentage change in quantity or percentage change in price, we can also calculate the price elasticity of demand for a particular product by this particular formula. Price elasticity of demand equals to change in quantity over change in price times initial price over initial quantity. The two formulas are all the same, just that they are expressed differently. So we are saying that the price elasticity of demand equals percentage change in quantity over percentage change in what? In price. Okay. Or price elasticity of demand equals change in quantity over change in price times initial price over what? Initial price. They are all the same. Okay? They are all the same. For instance, this leads to that. Okay, from this formula that we are able to draw, this particular formula for calculating the price elasticity of demand. From here, you can see that percentage change in quantity or percentage change in what? Price is our elasticity of demand formula. This can cancel this, leaving us with what? Change in quantity over what? Change in price. But we know that this change in quantity is the current quantity minus the previous quantity divided by what? The previous quantity. That is how we measure change. So the change in quantity here is the same as, let's say, Q1 current quantity minus Q0 previous quantity divided by what? Q0 to the previous quantity. And this is divided by change in what? Change in price. How do you measure change in price? We can measure change in price by the current price, say B1, minus previous price, say B0, over what? The previous price, B0. Okay. Let's represent Q1 minus Q0 as the change. So that this equalizes change in what? Q. That is Q1 minus Q0. We want to represent that by change in Q. And that will be divided by what? Q0 divided by P1 minus P0. Let's represent that as well by change in what? Price. And that is also divided by what? P0. We can change this symbol to multiplication. And when we do so, we invert the expression here. So that when it changes from division to multiplication, we invert this. So that we have P0 over Q. Change in what? Change in P. If we arrange this term By bringing the change together, we are going to have change in quantity. Multiplication we know is what? Cumulative. So we can bring this change before the Q naught. So that we have change here over change in Q here divided by change in P times this initial P over this initial what? Quantity. We realize that this is the same as that. So from this formula, we actually do. So they are all the same. Okay, just that they are expressed what differently. However, you should pay attention to the fact that when you are given a particular situation to handle or question or price resolution, the type of formula to use, either to use this or to use that, depends on the amount of information available in the question. If in the question you are giving a percentage change in price and that's a percentage quantity, then you have to use this formula. However, if in the formula, in the question, you are not giving that information, then you have to use this other formula. Are we together? All right. Now we have different types of still, but yeah, not that. Then, so you have different types of price. No, you cannot do it. So we want to end here and look at the various types of elastic next week, where we look at the relatively elastic, relatively inelastic, unitary elastic, unitary inelastic. Sorry, unitary elastic, relatively inelastic, and relatively what? Elastic types of elastic. Any questions? Any questions? You have 3 minutes. All right. In the absence of further questions, we'll end here and continue. As somebody said, the bullshit. I had a class somewhere where I was for 3 hours. I continuously asked any question, any question. Then one lady, she kept quiet the whole of the 3 hours. So 5 minutes to 3 hours, she said, "Sir, I have a question." I said, "What's the question?" Then the bullshit.
And now that this is
All right. A small announcement. Please, the furniture that is provided, if people kindly sit on the chairs and not on the tables. The tables are not strong enough. So that weight the table can be part of the furniture for us. So we're going to put this chairs out. All right. So and yes, it's your
100%.
Yes. All right. Yes.